Hello everybody, I am Ben from Team Panic, and today we're going to be talking about the weapon system on my 150 gram combat robot, Don't Need Roads. Now, this is the one that I've already done a video on the design of this thing and getting all of the design up and running, but there have been a few changes since that video and I just wanted to quickly cover them. And most of them have been in the weapon system. So this robot has always been a drum spinner, and I did cover the weapons in the last video, but just quickly kind of from left to right here, these up to the grey one in the middle here, this is where we got up to last time, and then this is a new weapon, and there's a new weapon on the actual robot itself. So we're just going to have a quick little chat about these. So on the left over here is the first iteration of the drum. It's actually off of a design from another YouTuber, Robert Cohen, who has done one of these, but he did his out of aluminium, and he built his into an American ant weight, I'm pretty sure, which means he had more weight to play with. I did mine out of 3D printed plastic, and I didn't have any bearings. I actually just used some brass bushings in the end. And this thing was okay, but it lacked any real grip, and it didn't really have teeth. These screws didn't really work very well at all. And so we moved on to these, which are 3D printed drums, and they have pencil sharpener blades stuck in them. But as you can see, these don't have any captive nuts or anything in them, so they literally just had the screw going straight into the plastic, and I very, very quickly lost 2 of these pencil sharpener blade teeth. And also, as you can see here, this is the big issue with having a drum in a horizontal spinner fight. Often the drum will get hit and take chunks out of it, especially when it's made out of plastic. So the next iteration up from there was pretty much the same thing, but this time we had captive nuts held in place with epoxy, and this worked relatively well, but as you can see, captive nuts got ripped out or the actual tooth got damaged. So these pencil sharpener blades aren't very strong steel, and I kept losing them. And in actual fact, that's what happened with this guy as well. As you can see, it's the same deal. Even though I've strengthened the actual drum and stopped it from getting hit, because as you can see, this guy here is still getting hit and having some damage taken to it. So I strengthened the drum with aluminium tape, but it's still losing teeth all the time, and I ended up having to like hot glue and epoxy the blades in, and even then I still managed to lose a couple. And then finally, we get to this. So this is a 3D printed beater bar. So the difference between this and a drum is pretty obvious. This is a nice thin piece of plastic like this. The drum is a nice round shape. And yeah, these guys are designed so that a horizontal bar is going to miss while it's halfway through its swing, and then it's actually going to contact as it rises up on the rising edge. But once again, these guys are using those pencil sharpener blades, and the pencil sharpener blades break. Even though there are actually captive nuts in here, it still didn't hold up very well at all. And that moves us on to the actual current design that we have. So this is a steel beater bar. So this is 3mm steel, and this is a hand-cut beater bar, which is actually a huge, huge issue, because as you can see, I can spin it round. Actually, that's the bad side there. That side, this little front section, is actually slightly higher than everything else. So this spins nice and freely through here, but then when I spin it 180 degrees, that bit hits the table, and as you can see, as I move it, it moves the robot, which means that when this thing runs, it hops, and it hits the table, and the whole robot kind of bounces up and down all over the place. So on the whole, I like the idea of the metal weapon, but the actual execution of that is really bad right now. So what we're going to do in today's video is we're going to upgrade this with a couple of things. First of all, we need a bigger motor in here. This motor is pretty tiny, so we're going to jam in this guy, which should actually provide us just a little bit more torque to get that weapon bar moving a lot quicker, and also to power through on those hits, which will be really good. And then we're also going to upgrade to an actual beater bar. So we have this guy here, which is a water jet cut 3mm steel beater bar, and this thing is actually about 19 grams, so it's a step down from this bar, but it will actually be stable, and it will, because it's symmetric and water jet cut, it won't hit the ground like this one does. Also, this one, like I said, is 19 grams, so I got myself cut a couple of different variations of this just so that I have some choice when it comes to weight. So this one's 19 grams. This one here is 26 grams. We have a couple of other variations as well. This one here is 24 grams. And then I have my personal favorite, this guy here, which says Team Panic and Team Panic. So this one here is also about 26 grams. So we're going to redo the chassis for this thing, see where it's sitting weight-wise after we've jammed in the new big motor, and then we're going to determine which one of these new beta bars is going to go into it, because we definitely want one of these new beta bars. Hopefully we have enough weight to get in the team logo beta bar, because these things are really, really cool, and I really want one of these in there, but we'll have to see how we go. And there we go, we have the brand new version of Don't Need Roads. So this has actually come along quite well. As you can see, the motor does indeed move the new weapon bar. However, if we just quickly jump this on the scales, like that, you will see it's 152, 151 grams, which means that unfortunately we're not going to be able to use the team logo weapon bar. This one here, the Team Panic weapon bar, is going to have to go because it's too heavy. So we're going to have to swap back over to this little guy over here. This is a little bit lighter. I think this is about 19 grams. So it will shave a couple of grams off this whole weight, and it'll also mean that we can actually put some reinforcements around the outside as well. Either some alley tape or epoxy some aluminium to the outside, just to give it a little bit more strength and especially protect this battery in the back here. I like having some aluminium across the back, because otherwise, yeah, the battery that sits in here is very open and exposed. But first, let's see how this thing actually spins up and if the change of weapon has actually done anything to help us out here. Yeah, so there we go. It turns out that the metal on this actual motor is a little bit too slippery, and as soon as we hit something and this weapon bar stops, yeah, the rubber band just slips. Which, I mean, it's supposed to slip, but it's not supposed to slip this much. Like, I am able to turn this without that motor turning at all. That's not a good thing. So, I've got two options from this point on. I'm either going to 3D print something that sits on this motor shaft and does the spinning, or I could literally just apply some epoxy and or hot glue onto the end of that motor shaft to act as a gripping agent, which will help the motor turn this weapon. So one of those things is going to happen between now and Maker Faire. So I'm going to Adelaide Maker Faire, so I'm going to be fighting this and many other robots, or I say many other, I'll be fighting 3 other robots while I'm there. So if you are in Adelaide and want to have a look at some of the robots that I've built firsthand, come on down to Adelaide Maker Faire very, very soon. And yeah, hopefully this guy will be up and running and fighting there. I do need to fix this issue, but I don't have time to do that in today's video. So that's going to be the end of this one. Hope you guys enjoyed that one, and I will see you in the next video.